Alright, so I'm going to work a few problems from your text review so that you kind of know what's going on. So on number 1, A, B, and C, for each of these vectors, they want you to find its magnitude. To find its magnitude, you need to know the formula. The formula is the square root of A squared plus B squared. And A is the number or the coefficient in front of the I, and B is going to be your number in front of the J. So for this problem, I'm going to have the square root of negative 5 squared plus negative 12 squared. Now I could just go type up my calculator if I wanted. So the square root of, parentheses, negative 5 squared plus negative 12 squared equals 13. So the magnitude of A is equal to 13. You're going to do the exact same thing for B. Let's go look at C. So this is my A again, and this is my B. So I'm going to the square root of negative 2 squared plus 3 squared. So again, I'm going to go to my calculator. Square root of, parentheses, negative 2 squared plus, parentheses, 3 squared. This time I get a decimal. That means this must not have been a perfect square. So what is negative 2 squared? Well, negative 2 squared is 4. 3 squared is 9. So 4 plus 9 is the square root of 13. So this answer is simply the square root of 13. All right, on to A, B, and C, they want me to use these two vectors that were drawn in order to add, subtract, and then multiply and add. So I have to figure out how to write these two vectors. So the first thing I'm going to do is I'm going to write vector W. When you're writing vector W, you need to figure out, as I go from right to left, because that's the way the arrow is going, how many units did I move to the right? Well, I moved 2 to the right. So that's my I, my horizontal. And how many did I go down? 1, 2, 3. And because I went down, it's minus 3. So the A is your horizontal distance, and the B is your vertical distance. Vector V, to get to this arrow over here, I'm going to go left 1. So negative 1I, or just negative I. And then I'm going to go down 1, 2, 3, 4. And since I went down, it's minus 4J. So again, your horizontal distance is your A, it goes with your I, and your vertical distance is your B, and it's going to go with the letter J. All right, so 2A wants me to take these two vectors and add them together. And I'm just going to add the components. I'm going to add the I's with the I's and the J's with the J's. So when they ask me to add vector W and vector V, 2I plus negative 1I is going to give me positive I. And then I'm going to say negative 3J plus negative 4J, and that's going to give me a negative 7J. And you do the same thing for B. For C, you're going to multiply V by 2 and then add W. Y'all seem to have a harder time with the subtraction, so I'm going to do that one. So again, we're going to do the same thing. I'm going to start with the I. I'm going to say 2I minus a negative 1. Well, 2 minus a negative 1 is actually a positive 3. And in case you forgot, 2 minus a negative 1. Hey, it's 3. And then I'm going to have negative 3 minus a negative 4. So I'm going to type that in again. Negative 3 minus a negative 4. And that's going to give me a positive 1. So I can just put a J. All right, so let's go look at number 3. On number 3, they want me to name the symmetry of the following relations. And they give me 2 graphs. And they also give me 2 equations that I could simply put in my calculator if I wanted to. So this first graph right here is symmetric to the y, because I can take this right side of the graph and fold it right over. So this is symmetric to the y. Because it's symmetric to the y, we're going to call it even. This one right here is symmetric to the origin, which means I can flip it over the y and then flip it over the x and it lands on top of itself. We also call this an odd function. You do the same thing for both of these equations. You could type them in your calculator, solve it for y. Number 4 wants me to draw and graph and write an equation of an odd function. And number 5 wants me to draw the graph and write an equation of an even function. So I'm going to do number 4 and 5 real quick. If it's an odd function, it has a characteristic of going up on the right and down on the left. An example would be y equals x to the third. For an even function, they're usually gonna, if it's a positive even function, they're gonna both arms of the function or the polynomial are gonna go up. And an example of that would be y equals x squared. On number 6, it says from the list of parent functions below, circle those that are continuous. A function is continuous if you don't have to pick up your pencil as you're graphing it. It's also continuous. An easy way to tell is if it doesn't have any asymptotes. So a linear equation doesn't have any asymptotes. Quadratic, exponential, square root, absolute value. All right, the reciprocal function, this one has asymptotes, so I'm not going to pick it. So does the reciprocal squared. Sine doesn't have any asymptotes. Cosine doesn't have any. Cosecant, secant, tangent, cotangent, these all have asymptotes. And there we go. There's all my continuous functions. On number 7, a and b, they want me to find the inverse of each. In order to find the inverse, what we used to do is we would take the x and the y and we'd flip them, and then we'd solve for y. So this right here says f of x, which really just means y equals the quantity x minus 5 squared. So I'm going to flip my x's and my y's. And now I'm going to go solve this for y. So to solve for y, I have to get rid of the square. To get rid of a square, we're going to square root. So I've got the square root of x is equal to y minus 5. To get the y by itself, I have to get rid of the minus 5. In order to get rid of the minus 5, I'm going to plus 5. So y inverse is going to equal the square root of x plus 5. And this plus 5 is not under the square root. And you do the same thing for b. On number 8, they want me to solve each of these equations down here. They're all exponential equations. When you have exponential equations, your goal is to get like bases. So let's look at number 8a first. So 8 and 4 can both be made using a 2. 2 to the third is 8, and 2 squared is 4. Once you have like bases, you can set your exponents equal. So I'm going to have 2x equals 3, and then I solve. So x equals 3/2. Letter B is going to be very similar. I'm going to try to make both of these have the same base, and again, it's going to have a base of 2. So this one's already done for me. I have 2 to the 3x minus 1. This one is 2 to the third, but it's in the denominator. So I have to move it up, and when I move it up, I write it as 2 to the negative 3, and there's that x out there. Now I have my like bases of 2, so I'm going to go set these equal up here. 3x minus 1 equals a negative 3x. I'm going to move this 3 to the other side, and I get negative 1 equals negative 6x. I'm going to divide by negative 6, and x equals 1/6. Okay. For 9 and 10, they give me some equations, and you'll have these equations on your test, so you don't have to memorize these. It says Robert is investing his money to buy a house in 10 years. So that's my time. He will deposit $7,450. That's my initial at a Members Choice Credit Union at 7.5%. This is your R. And it's compounded monthly. Compounded monthly gives you your N. How much money can he withdraw in 10 years? Okay, so I got to figure out which one of these equations I'm going to use. This is the one I'm going to use. The amount is going to be equal to what we started with, the initial, parentheses, 1 plus, because it's growing, at a rate of, it's 7.5, which would be 0.075, over N. And N is the number of times that you compound. If I'm compounding monthly, that means it's happening 12 times. And then I'm going to raise that to the N times T. N is 12, and we're going to do this in 10 years. Okay, so there's the equation, and I would simply go type this in my calculator. I like to type this part in first and then multiply, but it's really up to you. So I have 1 plus parentheses, 0.075 divided by 12, close them. Notice how my parentheses are closed. Raised to the 10 times 12, which is 120. And I'm going to take that answer and multiply it by 7450. And we find out that we will have $15,734.88. Gosh, that's pretty easy. And that was number 9. Okay, so 10 is going to work the same way. Let's turn the page. And on 11, they want me to simplify each of these expressions. And they want you to use your properties in order to make these all smaller. So we're going to remember that addition means multiplication, subtraction means division, and if you have a number out front, like on A right here, it means it used to be an exponent. All right, so I'm going to go do 2 of these real quick. So this one right here has addition, so I'm going to remember that that means multiplication. This 3 out front means it used to be an exponent. This 2 used to be an exponent, and again, we just said addition means multiplication. So when I go rewrite this, I'm going to write it with 1 log, just 1. And I'm going to go multiply all of these together. So I'm going to have m into the 3rd, p to the 2nd. Okay, let's go do one more. Let's go do b also. So again, the 2 is going to become an exponent. This minus means that I'm going to divide, and this plus sign means that I'm going to multiply. We're going to go rewrite this as 1 log. So log c squared divided by d times e. There you go. All right, number 12 says write a log expression to represent the value of x. So they want me to solve these for x. In order to do that, I'm going to look at a first. I'm going to do it over here. We're going to take the log of both sides. So log 3 to the x equals log of 25. I can use these properties that we just did up here backwards. Because I have an exponent, I can pull it out to the front and say x times log of 3 equals log of 25. This says x times log, so to get x by itself, I do the opposite. So I'm going to divide log of 25 by log of 3. And you do the same thing here and the same thing here. All right, number 13 says which of the following is not equivalent to 7 raised to the x equals 12. Okay, so first thing, we can use the rules that we just talked about. I can switch this around and change an exponential to a log. In order to do that, we keep the same base, so it's going to be log base 7, and then I switch these of 12 equals x. So log base 7 of 12 equals x. Okay. I could also go solve this by what we did up there. I could do log both sides, and I get log 7 to the x equals log of 12. I'm going to pull that out front, so x log 7 equals log 12. And I'm going to divide, so x equals log 12 divided by log 7. Okay, so it looks like this is what they were trying to get me to do. So first thing I did was I logged both sides, and I pulled it out front. So this has got x log 7, log 12, so this one's there. This one says log 12 divided by log 7. I have this. This one says I log both sides, so this is the one that's not equivalent. It wasn't anywhere in here. It's also not the first one I wrote down. It needed to be log base 7, so this is the one that wasn't it. Okay, for 14, they want you to identify something as arithmetic, geometric, or neither. So something is going to be arithmetic if we're adding or subtracting to get to the next term, and it's going to be geometric if we're multiplying to get to the next term. So if I'm looking at B, I'm trying to figure out how I'm going from -7 to -4 to -1. Well, if I add 3, I get -4. If I add 3 again, I get -1. If I add 3, okay, so this one's arithmetic. And my common difference is that I'm adding 3 over and over and over. Let's go look at C. I'm trying to figure out how am I getting from -9 to -3 to -1. Well, I'm not subtracting the same number every time, but it looks like I'm multiplying. And it looks like I'm multiplying by, looks like a third. Let's see, -9 times a third is -3. -3 times a third is -1. So this one is geometric, and your R, your common ratio, is 1/3. All right, on 15 and 16, they're using these equations that are written up here. For each one of these problems, before you can pick an equation, you have to know whether it's arithmetic or geometric. If something is arithmetic, you're going to use the equation up here that has the n in it and the d, and you're going to use this one over here. If something is geometric, it will have an r in it. So these are my geometrics because they have r's. All right, so 15 says, given the sequence 12, 18, 24, and 30, ... 204, find all of the following. I'm just going to do a few pieces of this. So I'm going to decide if it's arithmetic or geometric first. 12 to 18, 18 to 24. It looks like I'm adding, and it looks like I'm adding 6. So this is arithmetic, and my common difference is 6. All right, so the first one thing they asked me to do is find the total number of terms. If they're asking you for the number of terms, they're asking you to go find n. So I need an arithmetic equation that has, that's going to find the number of terms, which is this one right here. So I'm going to write down an equals a plus n minus 1. So an is going to be your last term, which is 204. A right here is your first term, which is 12. I'm looking for n, and my common difference is 6. And we're going to go solve this equation. There are lots of ways to solve it. I'm going to subtract 12 first. So I'm going to have 204 minus 12, and that's going to give me 192. So I have 192 equals 6 times n minus 1. It doesn't matter if I move the 6 over here. I'm going to go ahead and divide both sides by 6. So I'm going to take that 192 and divide it by 6. And I get 32. And now all I have left to do is add 1. So n equals 33. There are 33 total terms. Let's see, what else do I want to do in this section? Let's look at E. Let's talk about what it means to be recursive. When they ask you to write the recursive, what they want you to do is write the first term and then how do you get each additional term. So anytime you write a recursive problem, you always start off by writing your first term. So A1 equals 12. And then you're going to write your next equation for the nth term, and you want to use the previous. So what did I do to 12 to get to 18? Well, I added 6. Well, the way you write the term previous is you write a n minus 1, that means previous, and then plus 6. Okay, let's go look at 16 now. On 16, I have to first figure out if it's arithmetic or geometric. From 5 to 15 to 45 to 135. This is geometric, and my r is 3. I'm multiplying by 3. Okay, on this one, I'm only going to go do the sum of the first 8 terms. I'm going to go do B. If they're asking you to find a sum, it means I need an equation with an s in it. Because it's geometric, I want this one right here that has the r. So I'm going to go do this one. So the A stands for the first term. My first term is 5. So I'm going to find the sum of the first 8 terms. So 5 times 1 minus r, my r is 3, raised to the n, your n is 8, divided by 1 minus 3. Okay, and then you're going to type that in your calculator. So here we go. All right, I like to type all of this in first, and then I multiply it by 5. So parentheses, 1 minus 3 raised to the 8th, divided by, I know what 1 minus 3 is, divided by negative 2. And I get 3280, and I'm going to multiply that by 5, and I get 16,400. That's it. It's that simple. So we practice arithmetic and geometric. We practice finding the number of terms. We practice writing recursive, and we practice finding the sum of the first 8 terms. All right, 17, 18, and 19 were all about our polynomial unit. On 17, it says graph each of the following functions and identify the requested information. You're going to get to use your graphing calculator, so when they tell you to graph it, go to your calculator. So the first thing they want to know is the zeros. So I could tell the zeros without graphing it, but since I have the access to this, I'm going to go ahead and use it. So I'm going to type everything in my y equals. I'm going to go hit graph, and I'm going to notice that it touches the x at -3, -1, and +5. When they ask you for the zeros, they just want to know where is it touching the x. So -1, +5, and -3. And we're done. Okay, let's go look at letter B. They give me a different equation. Again, you just type it in your calculator. Parentheses, x plus 2 squared, parentheses, x minus 1. I'm going to go look at my picture. And they're asking me for the relative maximum. So when they ask you for the relative maximum, they're looking for somewhere where it like peaks. And it peaks, it looks like right here at negative 2, 0. So I would say my relative maximum was at negative 2, 0. I wouldn't say there are any others because it goes up, it peaks, it comes down, then it goes up, looks like for infinity. So this is really the only little peak that I have. Okay, the next one we're going to look at is D, because I want to talk about the word range. So let's go type this one in our calculator. X plus 2 raised to the third. Okay, I'm going to try that again. X plus 2 raised to the third, parentheses, x minus 3. And when they ask you for the range, we're looking vertically. We're trying to see what is my highest point and what is my lowest point. Well, it looks like, by looking at this graph, that it's going to go up forever. I'm trying to see how far it goes down. So I'm going to trace. Actually, I'm going to go to my window first. And it looks like it goes down to at least negative 64. Okay, so I know when I'm looking at my picture, or if I decide to trace, I need to go way down to 64. Oops. Taking a little bit. There we go, we're starting now. Oh, I'm going the wrong way. Sorry. Alright, here we go. Negative 60, negative 64, negative 65.5, negative 65.8. So it looks like that's my lowest point. I wouldn't worry about being too exact. You know it's going to be around negative 65-ish, and then it's going to go off to positive infinity. So when they ask you for the range, I'm going to put negative 65, right-ish, and then it's going to go off to positive infinity. All right, so now let's go look at 18. 18 is asking you to find the roots. When they ask you to find roots, it's the exact same thing as when they ask you to find zeros. They just want to know where does it touch the x. So we're going to go type this in our calculator. 3x raised to the third plus 17x squared plus 18x minus 8. I'm going to look at my picture first. And it looks like I have 1, 2, 3 different roots. It looks like 2 of them are easy. Negative, it looks like negative 2 and negative 4. So let's go look in our table. Oh, yep, one's at negative 2. And yep, there's another one at negative 4. So I know 2 of my answers are at negative 2 and negative 4. I do know that I have another one, and it's right over here. I just know it's going to be a decimal, but I'm not quite sure what it is. So what we're going to do is we're going to do some synthetic division, and then whatever we have left should give me a quadratic, and then I'm going to use my quadratic formula. So it's up to you which one of these you want to use. I'm going to use the negative 2. I'm going to do my work right down here. So when you do synthetic division, you put your 0 out here. You bring down all your coefficients in order. You drop your first number, and then we're going to multiply, subtract, multiply, subtract, multiply, subtract. Now I already know this is going to be a 0 at the end because I saw that it touched the x. So if I don't get a 0, I messed up. 3 times negative 2 is negative 6. 17 plus negative 6 is 11. 11 times negative 2 is negative 22. Negative 22 and 18 is negative 4. Negative 4 times negative 2 is positive 8. Hey, and I got the 0 just like I thought I would. So what I'm going to do is I'm going to take what's left, which would be 3 as my coefficient. It's always one less exponent than what we started with. X squared plus 11x minus 4. And I know this is my A, this is my B, and this is my C. And I'm going to go use my quadratic formula. So x equals the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. I'm just plugging into that formula that you've known since, I don't know, I think 7th or 8th grade. And we're just going to type in our calculator. I'm going to have negative 11. I'll do the plus one first. Plus the square root of 11 squared minus 4 times 3 times negative 4. I'm going to arrow out, hit enter, and then I'm going to divide by 2 times 3, which is 6. I get this repeating decimal, and I'm going to just math frac it, and I find out that it's 1/3. hey, I don't even have to go find the other one. I know it's -2, I know it's -4, and I knew by looking at my picture I was going to be a positive fraction over here. That must be the positive fraction. Okay, number 19. So all of this went to 18. And you do the same thing for B and the same thing for C. On number 19, they want you to write a polynomial for this graph. A couple things they want you to notice is that it crosses at -1, which means you had to have a factor of x plus 1, and it had to be an odd power. It touches where x equals 3, so that means it had to be x minus 3 for a factor, and it had to be to an even power. Okay, and that's really all they wanted you to do. All right. On number 20, it's kind of like number 19. We just kind of did that. The only thing we really didn't talk about, it's right here, is I know the leading coefficient is positive or negative because the end behavior is blah, 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 blah. You can tell that this is going to be an even powered polynomial because the ends are going the same direction. Either both will go up or both will go down if it's even. So I know it's going to be even. And because they're both going up, I know it's going to be a positive because x goes to infinity, so do the graphs. They go up to positive infinity. We could write the possible equations like what we just did. So it crosses at x minus 5, so we write x plus 5 to an odd power. It crosses at -1, so x plus 1 to an odd power. It touches at 5, so x minus 5 squared. So now that I did this, I could probably go answer this a little better. This is a squared, this is a first, and this is a first. So this is going to be a degree 4. It's 2 plus 1 plus 1. And then it wants to know where's the function increasing. They just want to know where is it going up. It's going up from whatever this number is to there. And it's also going up from here to there. Those are my two intervals where I'm increasing. 21 and 22. It says find the vertical asymptotes, find any removable discontinuities, and find any x-intercepts. So when you're doing number 21, the first thing you're going to notice, or the first thing I notice, is that I have an x plus 1 here and an x plus 1 here. Anytime you have an x plus 1 that's going to cancel, or I'm sorry, anytime you have two factors like this that'll cancel that have x's in it, that's going to give me a removable discontinuity. So I know I'm going to have one. So the first thing I'm going to do is I'm going to go rewrite this as x plus 3 parentheses x plus 1 over x minus 4. Because this was an x plus 1 squared. So I knew that this and one of these were going to cancel. So this is what's left. To find the whole, what you're going to do is you're going to plug in here of what would make this 0. So x plus 1, for x to be a -1 would make this 0. That means when x is -1, I want to know what is y. So I go plug it in right here. -1 plus 3 is -2. But -1 plus 1 is 0. 0 times -2 is 0. 0 divided by anything is 0. So the whole is at -1, 0. They want you to find your vertical asymptotes. Your vertical asymptotes are found right down here on the bottom. So what would make this 0 if x was equal to 4? And then they want to know if there's any x-intercepts. So I would simply go type it in and see if there are any. So I'm only going to type in this part right here. So I'm going to have on the top, you got a double parentheses, you got x plus 3, x plus 1, close them again, divided by parentheses, x minus 4. I'm going to go look at my picture. Oops, go to, where did I mess up? Oh, that should be a 4. I mean, 1. Alright, so it looks like it's touching right around here somewhere. So I'm going to go to my table. Oh, and in my table I can see that it's got a 0 at -3 and a 0 at -1. So I have two x-intercepts. I have an x-intercept at -3 and an x-intercept at -1. Hey, I wonder if that has anything to do with this. Hint, hint. 22 is going to work the same way. So on 23, A, B, and C, they're asking you different questions about these graphs. So the first thing you're going to notice is you have a 1 over x minus 4 squared. Okay, that's your reciprocal squared function. And this minus 4 means it's going to go right 4. And this plus 3 means we're going to go up 3. Okay, and this is the one, because it's positive, they go in the same direction. I always said it looked like a volcano. So this says, as x approaches 4 from the right, because it's positive. So as x approaches 4 from the right, what do you notice is happening to my y values? Oh, well, they're going off to infinity. Okay, letter B, they want me to graph that one. So for this one, there are no vertical asymptotes, but I do have a horizontal one at -1. The rule was you go up one, right one, and approach the asymptotes. I'm going to go left one, down one, and approach the asymptotes. And they want to know if it has any intersects. Well, it never touches the y, but it does touch the x. It touches the x right there at, oops, not -1, at 1, 0. So we'll do one more. This is the squared one again, so it's the volcano one. It's going to go left 2, and it's going to go down 5. I'll do it over here. I'm going to go left 2, 1, 2. Here's my vertical. I'm going to go down 5, 1, 2, 3, 4, 5. And again, this is the one that looks like the volcano. Okay, and they said this graph has some symmetry with respect to this asymptote right here, and that asymptote is the line x equals -2. Okay, so we're almost done. So 24 and 25 is what we just did when we were doing conics. So I bet you're going to be pretty good at these. So we'll start off with something easy. This one only has one square, so it must be a parabola. This has the word secant, so it has to be a hyperbola. This has 2 fractions squared equaling to 1, and there's a plus sign, so it has to be an ellipse. This has the exact same number out front, which means it's a circle. And this has a subtraction sign, which means it's a hyperbola. Okay. On 25, A, B, and C, they want you to write the equation in standard form and parametric. I'm going to go focus on letter B. So the first thing I want to do is find the center. It looks like the center is right here. So right now my center is at 4, 0. I also want to go ahead and find out this vertex right here. Will tell me what my A is. So A is the distance from the center to the vertex. So I'm at 4, 5, 6, 7, 8, 9. So I went right 1, 2, 3, 4, 5. It looks like it's 5. My A is 5. Sorry. Okay. Now I'm going to go find my B. My distance is from the center up, and it looks like I went up 1, 2, 3. So my B is equal to 3. Now that I know A and I know B, I should be able to write my equations very easily. So let's go ahead and write the standard one first. I know that this is an ellipse. And ellipses always start with x squared. It's a horizontal ellipse, so the a squared will go under the x. My center is at 4, 0, so it's going to be x minus 4 squared plus y squared equals 1. And then I have to put in my a squared and my b squared. A squared goes in the direction. It's going left and right, so it's going to go underneath the x, so 25. And then my b squared goes under the y. Okay, so that's the standard. Now we'll go do the parametric real quick. So parametric, we'll say x equals y equals. The a is going to go with the x because it's going horizontal, and we're going to use the word cosine t. The 3 is going to go with the y, and we're going to use sine t. And then we're going to put our h here. My h is plus 4. My k is 0, so I'm done. All right, so that's a little bit of everything we've covered since Christmas. Go ahead and finish the rest of the review on your own. Remember, you do have the answer key. It's right there at the back. So if there are any that you can't figure out, don't hesitate to ask. Good luck studying.